What's happening, Webster Groves? This is Hickson Middle School's Light and Sound or Wave Energy Unit, Goal 3, Video Notes. In this goal, you're going to be able to describe how changes in energy cause changes in loudness and changes in the pitch of a sound. So you're going to need to understand the properties of the waves that make loudness happen or make pitch happen. Okay. If you're going above and beyond, if you're surpassing the goal, you're able to predict how changing the energy changes the sound of a wave. Okay, so here we go. First, we need to know, what is loudness? Okay, well, loudness is it describes your perception of the energy of a sound. In other words, loudness describes what you hear. Okay, if you hear how loud a sound is, you are describing what you are hearing. So, sound is an energy. We can see that when we look at these speakers go. We can see their movement and how sound moves through these speakers when they vibrate. And when they vibrate like that, that is causing sound waves. So we need vibrations in order for sound waves to happen. So these speakers are definitely a source of sound. And due to the amount of their vibration, I would be guessing that's pretty loud. So how does energy affect the loudness of the sound? Okay, well, in general, the greater the energy used to make the sound, the louder the sound. So greater energy, louder sound. Okay, and the opposite is also true. The more energy you use to pull the guitar string back, the louder the sound when you let the string go. Okay, so imagine that, pulling a guitar string. The further you pull it back, you're putting more energy into it, and so more energy is going to go into the sound, making it louder. This happened because the more energy you use to pull the string, the greater the amplitude of the string's vibration. It's moving higher and lower. A string vibrating with a large amplitude produces a sound wave with a large amplitude. Recall that the greater the amplitude of a wave, the more energy it has. Okay? So amplitude is related to volume and is related to energy. All of these things have a similar relationship. Okay? Greater energy means a greater amplitude, which is going to produce a louder sound. So loudness depends on the amount of energy and the amplitude. How does the distance affect the loudness of the sound? Loudness increases the closer you are to a sound source. This is pretty obvious. If you're right next to a speaker in a rock concert, you're going to be blowing your ears out. But if you're about a mile away, you might just hear it at a comfortable volume level. So imagine ripples spreading out in circles after you toss a pebble into a pond. In a similar way, sound waves spread from its source close to the sound. The sound waves cover a small area. As the wave travels away from its source, it covers more area. The total energy of the wave, however, stays the same. So same energy in a larger area equals lower intensity or more quiet sound. Okay? So dog in the pond, you can imagine if you were closer to that dog, you'd be getting lots of ripples in a small area. But if you're further away, you're getting fewer ripples and it's in a larger area. So the further away you are from a sound, the more the sound loses its energy. Okay, so sound loses energy over a distance. And that's why we don't hear things as well if we're far away from them than if we were closer up to them. Okay? So it has to do with the amount of energy and it decreasing over a distance. This is a great visual for representing that. Okay, so we have a speaker, and when you're up close, all of that sound is concentrated on your ear. Okay, then you walk a meter away. Now that sound could be concentrated over 4. So at 2 meters, the ear hears a sound with 1/4 of the intensity that it was at 1 meter. And then you move 3 meters away, the intensity has decreased to 1/9 of the sound than it was at 1 meter. So the further away you are, the more that sound spreads out, and when it spreads out, it loses its energy. How's loudness measured? The amount of energy a sound wave carries per second through a unit area is its intensity. The loudness of different sound is compared using a unit called a decibel, abbreviation dB. So that is how loudness or intensity of sound is measured. It is measured in decibels. Okay. Next, how loud is too loud? This is a question that's come up before in class. So the government research suggests that a safe exposure limit is 85 decibels for 8 hours a day. So some common decibel levels are, okay, we can see normal conversation. This is probably the level that I'm speaking to you right now, 60 decibels. If you have your hair dryer on for a long period of time, this could damage hearing. And what I found interesting was an iPod at peak volumes. You know, how many times are you listening to your iPod at its maximum volume? That's 115 decibels. So that can do some damage on your eardrum and on your hearing. Okay, so keep that in mind. Louder sound, more energy. More energy going into your ear could mean some damage. What is pitch? This is the second thing you're going to have to know in this goal. The pitch of a sound is a description or a perception of how high or low the sound seems to a person. Okay, so higher pitch, higher note, lower pitch, lower note. What does pitch depend on? The pitch of a sound that you hear depends on the frequency of the sound wave. Higher frequency, higher pitch. Higher pitch. So just know that the greater the frequency, more waves per second, the higher the sound is going to be perceived. Okay, and also the higher the frequency, the shorter the wavelength. You know, you notice a short wavelength here and a longer wavelength here. Okay, so that's another relationship. But what you need to know in this goal is higher pitch, higher frequency. Okay. How do you change the pitch when you sing? Well, to sing different notes, you use muscles in your throat to stretch or relax your vocal cords. Relaxing your vocal cords gives you a lower sound. When your vocal cords stretch, they vibrate more quickly and the air rushes by them. This creates a higher frequency sound waves that have higher pitches. When your vocal cords relax, lower frequency. Sound waves with lower pitches are produced. With musical instruments, it's a little different. You change pitch in different ways depending on the instrument. For example, you can change the pitch of a guitar string by turning a knob to loosen or tighten the string. Or you could change the guitar strings. A tighter guitar string produces a higher frequency, which you hear as a note with a higher pitch. Higher frequency, higher pitch. This is what you need to know. So that kind of wraps up the questions. This is a video in conclusion that gives us a great visual.
Today I'm going to be explaining sound, frequencies, pitch, and amplitude. And to better explain this, I'm going to be using tuning forks. Tuning forks are sound resonators that have a U-shaped pattern, and when they are struck, they create the same constant pitch. Now, sound is vibration of particles. And to prove this, I'll strike the tuning fork, and you can see that it's vibrating. To further explain this, I'll strike it again and put it in some water, and you can see that the vibration causes the water to move. Now, tuning forks are determined by their pitch, by the length of the rod. This one has a higher pitch, and this one has a lower pitch. You see that they are different sizes. Now, pitch and frequency are very close, but different. Pitch is the highness and lowness of a sound, and frequency is the number of vibrations per given time, typically in seconds. Now, amplitude is a little different. So this will always play the same frequency and the same pitch, but I can change the amplitude by how hard I strike it. Let me show you. The harder I strike it, the louder it gets. The amplitude can change from this. Now to further explain this, I'm going to use a sound whistle. The sound whistle is the same as a regular whistle, except the chamber can change. The chamber is what makes the frequency change. It makes a high pitch or low pitch. So you can see here. Now I'm using a program called Audacity, and I'm going to show you how the force that I use to play the instrument is going to determine the amplitude of the sound. I'm not going to change the frequency of the sound, but only the loudness or the amplitude. So you can see from the three wave heights that the first one has a lower height, the second one has a little higher, and the last one has the highest height. The last one has the highest amplitude, the loudest sound. The first one has the lowest amplitude and the lowest sound. Now I'm going to show you how, when the frequency changes, the pitch changes. Now I'm going to change this to a different audio track. I'm going to show you the spectrum of the way it is. As you can see at the start, I started out as a high note. The frequency was high. Then the frequency dropped, and then at the end the frequency increased again, and therefore the pitch went from high to low, back to high. For instrument to show you, they're called boom whackers. They're long, clear, plastic tubes. Same diameter, but different lengths. The long one makes this sound, and the short one makes this sound. My challenge to you is to figure out why the longer one has a lower pitch than the shorter one.
All right, so this kind of wraps up our goal. Goal is to describe how changes in energy cause changes in loudness and pitch of a sound. So know what causes loudness, know what causes pitch, and what that would look like in a wave. All right, well that's it, that's all. Thanks for watching. Later.